Hi class. Today our topic of discussion is surds from rational and irrational number. We are still continuing with chapter 1 from class 9. Now let us first see how can you define surds or radicals. Same thing. Now look over here. Suppose I take A as a positive rational number. I take n as a positive integer and of course n greater than 1, then nth root of A is known as surds or radical of order n. If A cannot be expressed as nth power of a rational number. We'll take an example and things will be clear. Look over here. Suppose I take cube root of 8 and I take cube root of 15. Now your n over here is 3, your A is 8. Can I write A as a rational number raised to the power 3? Of course. I can write this as 2 cube. Okay, we know the value of this is 2. This is my rational number. But look at this case. Can you write 15 as a rational number raised to the power 3? Not possible. Which means cube root of 15 is my surds or radical. Similarly, square root of 2, square root of 3, cube root of 16 or fourth root of suppose 25. These are all my surds. Am I clear? Over here, look carefully. The order is 3. Over here, we know square root, which means the order is 2. Over here, the order of the surds is 4. So that is the definition of surds. Now there are certain properties of surds which we should know. Look over here. First of all, nth root of A raised to the power n is equal to A. We know it. Suppose square root of 8 square is 8 only. Or you can say cube root of suppose 50 whole cube is 50 only. Am I clear or not? Second, your nth root of A multiplied by nth root of B will be nth root of AB, which means suppose you have square root of 2 multiplied by square root of 3, that becomes square root of 6. Look at this. Suppose we have nth root of we have nth root of A by nth root of B. We can write this as nth root of A by B. Am I clear? Few more important things. Look over here. I'm taking surds of order 2. Root of A plus root of B. Remember, this is not equal to root of A plus B. I see kids doing this mistake. Am I clear? Similarly, for example, suppose root of 2 plus root of 3 not equal to root of 5. Similarly, if you can say root of suppose 3 plus root of 3, this is not equal to root of 6. Instead, this is equal to twice root of 3. Am I clear? Similarly, if something is like, suppose 3 root 3 minus 2 root 3. So this becomes 1 root 3. That is root 3 only. Am I clear? 3 minus 2 is 1. Okay. Now look at few more things. Suppose A, B, C, D are all rational numbers, and this is your irrational number, root of P. Then A plus, if you write B root P is equal to C plus D root P, then we can say that A is equal to C and B is equal to D. Clear? And if you have something like this, look over here, suppose you have root A, root B, B2, irrational number, then if root of A is less than root of B, then we can say that A is less than B, squaring both sides. Or if suppose root A was greater than root B, then we can say that A greater than B. Similarly, if A is a rational number, and root B is your irrational number, and A greater than root B, then you can say A square greater than B. Or if A less than root B, then you can say that A square less than B. Remember, these are few properties of Surds. Am I clear? And all the Surds are irrational numbers. No doubt in that. Clear? Now look at the exercise from this chapter. Now look at exercise 1.4, sum number 1, part 1. Simplify root 45 minus 3 root 20 plus 4 root 5. Can we write this as 9 multiplied by 5 minus 3? 20 we can write 4 multiplied by 5, and this is 4 root 5. Okay, this is square root of 9 is 3, we know that, so 3 root 5 minus 3, and square root of 4 is 2, so that's 2 root 5 plus 4 root 5, which is equal to 3 root 5 minus 6 root 5 plus 4 root 5. Now 3 plus 4 is 7. 7 minus 6 root 5 is root 5. Done. Clear? Now look at part 6. Root 24 by 8 plus root 54 by 9. So this we can write 4 multiplied by 6 by 8 plus this we can write 9 multiplied by 6 by 9. Can we write this? Never cancel these two. Be careful. One is inside the root, one is outside the root. They won't cancel. Now root of 4 is 2. So that's twice of root 6 by 8 plus root of 9 is 3. So this is thrice of root 6 by 9. So this is 2 1 times, 2 4 times, 3 1 times, 3 3 times. So this becomes root 6 by 4 plus root 6 by 3. Now you take LCM, that's 12, 4 3 times. So 3 root 6 plus 3 4 times, 4 root 6. Now 3 root 6 plus 4 root 6 will be 7 root 6 by 12. And that's my answer. Clear? Look at this, 2 part 4. Simplify root 3 minus root 7 whole square. Very easy. A minus B whole square is what? A square plus B square minus twice A B. We have done this. Root 3 square will be 3, root 7 square will be 7 minus, this is 2 root 21. Remember, root A multiplied by root B will be root AB. So that's 10 minus 2 root 21. So that's your answer. Part 6. 4 plus root 5 multiplied by root 3 minus root 7. Very easy. We know how to multiply a binomial with a binomial. It will be 4 multiplied by root 3 minus root 7 plus root 5 multiplied by root 3 minus root 7, isn't it? This is 4 times root 3 minus 4 times root 7 plus this is root of 15, isn't it? Minus root of 35. So this will be as it is because the surds are different, so you can't simplify them. Am I clear? Now let us look at the next sum. Now look at sum number 5. Pretty easy. State which of the following are irrational. Look at root 4 by 9. We know root of 4 is 2 by 3. So this is a rational number, isn't it? If you talk about this is of course a rational number. There's no doubt in this. Look at this. Root of 7 by 25. Now 7 cannot be expressed as a rational number raised to the power 2. We can write this as root 7 and this is what? 25. 25 root is 5. But still this part will be inside the root only. 7 will be inside the root. So that's irrational. No doubt in that. Similarly, look over here. Root of 16 by 5. So root of 16 is 4, but root 5 is as it is. So this is also my irrational number. Pretty easy. Am I clear? Now look at sum number 8. Very important. Prove that the following is an irrational number. Cube root of 2. We have done a type of sum like this, square root of 5, to prove irrational by contradiction method in the earlier exercise rather. Look, we'll do by contradiction method. Contradiction method. How? We'll assume this as a rational number and see that our assumption becomes wrong. How? Let cube root of 2 be a rational number, which means cube root of 2 can be expressed as p by q, where p and q belongs to integer, q definitely not equal to 0, pq are co-prime, that's very important, which means they have no common factor except 1. Now look, cubing both sides. What do you get? 2 equals to p cube by q cube, which means can I write p cube equals to twice of q cube, which means p cube is a multiple of 2. Look carefully, which means 2 divides p cube, which means we can write 2 divides p, which means 2 is a factor of p. Can we write this? So now let us assume p equals to 2k, where k is your positive integer. Okay, and put the value over here in this. So instead of p, I'll write 2k cube equals to 2q cube, which means can I write 8k cube equals to 2q cube, which means can I write q cube equals to 4k cube, which means q cube is a multiple of 2, no doubt in that, which means 2 divides q cube, which means 2 divides q, which means 2 is a factor of q. Look at this statement. According to our assumption, there cannot be any other factor except 1. But over here we saw 2 is another factor, which is common in both, which means our assumption is wrong. And if our assumption is wrong, we can say that cube root of 2 is an irrational number. Done. Am I clear? Now look at the next sum. Look at number 10. write the number in ascending order. 3, root 2, 2, root 3, root 15 and 4. What we'll do, write all the numbers as the square root of one radical. How? Just look. Can I write 3 as root 9 multiplied by root 2? This I can write root 4 multiplied by root 3. This as it is. And this I can write root 16. Now look over here. This becomes root 18, root 12, root 15, root 16. Ascending means small to big. So 12 is less than 15 is less than 16 is less than 18, we know. So root 12 also will be less than root 15, will be less than root 16, will be less than root 18, which means twice root 3 will be less than root 15, will be less than 4, will be less than thrice root 2. Done. Now look at the last sum of this exercise, sum number 12. Arrange in ascending order. See, the radical is different. Over here is 3, the order is 3. Over here the order is 2. Over here the order of 6. Okay, look carefully how I do. This I can write 2 to the power 1 by 3. This I can write as 3 to the power 1 by 2. And this I can write as 5 to the power 1 by 6. Now 3, 2 and 6. LCM of 2, 3 and 6 is 6. What we'll do, we'll try to make the order same. How? Look over here. Can I write this as 2? See, 2 multiplied by 1 by 3 into 2. It remains same thing. See, in the power, what I did, I multiplied the numerator and the denominator by 2. Okay, I can do like this. Similarly, over here 3 to the power 3 into 1 by 2 into 3. Similar this as it is. Okay, so this becomes 2 square is 4 to the power 1 by 6. This becomes 3 cube is 27 to the power 1 by 6, and this is 5 to the power 1 by 6. Now ascending from small to big. So this is the smallest. So 4 to the power 1 by 6 is less than 5 to the power 1 by 6 is less than 27 to the power 1 by 6, which means cube root of 2 is less than 6th root of 5 is less than square root of 3. Am I clear? So this was the last sum. In the next video, we'll see a very important thing that's called rationalization. Okay? Till then, take care.